Afternoon, everyone. I hope you enjoyed your lunch and refreshed, ready for the next session. So my name is Has, and today I'm talking about solution architecture for cloud applications. So this is not neural network. This is not machine learning. This is not cracking math. This is really more about my experience in transitioning from being a technical lead developer into a solution architect. So although most of the concepts that we're going to be talking about is architecture, it would apply not only to cloud, but also to mobile applications and on-premise web. So just at the beginning, any show of hands for how many architects in the room? Okay. Not many. Technical lead? Yeah, cool. That's good. So I have nothing against architects. I personally moved into the solution architect role about a few months ago. I've been working as a consultant, technical lead for the last 2-3 years, and recently moved into this solution architect role. So I'll share with you the challenges and the things that I'm seeing. And this is all from my perspective. This is just my perception of things. So take it with a grain of salt. So just a bit of warning, architecture can be very fluffy and very abstract. I promise I won't bore you with any UML diagrams or anything. I'll try to make it as relevant as possible, but just bear with me. Plus, just to add to that, I didn't really have enough sleep last night, so I flew from Melbourne last night. So just to start, let's start with a contentious subject, developer versus architect. So again, this is just my perception on things. This is not a research paper saying, OK, this is how things are. So you would find that there are a lot of young developers, and more you're seeing people coming into the development space because it's very interesting. It's a very enjoyable thing to do. But you wouldn't see architects just going out of uni, going into the architect role. So ideally, you would have at least 10-15 years of experience. And it depends on what sort of architect you are. You're probably going to need more. So naturally, the age of an architect would be slightly higher or probably even more higher than of a developer. In terms of leadership, leadership is not really a title that you give to somebody. So some people are just natural leaders. So you'll see many developers are really influencers in their teams. But it's not really, they don't have the authority. It's not really part of their job responsibility. But you see, with architects, it's really part of their job. They are paid to do that. So they need to make sure that they are steering the conversation in the right direction. Now, with security and quality, they are pretty much on all layers, on all levels of software development. So you find them everywhere. And that's why architects or developers, they would probably work collaboratively on that. Now, in terms of governance and vision, for most developers, they don't really think that it's part of their jobs, and I think they are right in thinking so. But for architects, it's really, if something goes south, it's going to be really you to blame, because you are paid to make sure that the development is going in the direction that the organization wants. Stakeholder management, again, it's part of the architect role, not really much so from the developer perspective. And lastly, but quite importantly, the pay. So when you go from a developer into an architect, there is a very decent jump as well. Now, I'll be very honest with you. I thought it's more fun than it is when I'm doing it now. And there are days or sometimes even weeks where I wish that I just go back into development because I just want to focus on doing shit done rather than just talking to people and going into meetings and trying to explain things and just drawing them on whiteboards. So the point I'm trying to make here is, although it might sound catchy to be an architect, it might not be the best thing for you. And I'm still, myself, trying to figure out whether it's really best for me or maybe I just move into software development. So I mean, as a developer. So you need to think about whether it's the best thing for you or not. Now, architects also come in different colors and shapes and forms. So I thought it would be good to just take a moment and distill what the different titles are. So the ones that are related to solution architecture that we're talking about here, there is one which is the kind of the umbrella, which is the enterprise architect. The enterprise architect, normally you would see it in a big enterprises where they have, mostly in, say, in finance or in government or in health, you will see that they have complex systems, they have multiple components, so they would have enterprise architects. Their design would be very high level. Normally, they would have at least 20+ years of experience. They don't really do much technical detail in their design, and they are spanned across the organization, multiple projects, multiple teams. And then underneath that, you will have the solution architects, which is what we're talking about today, where they are focused on the solution. So there would be multiple components. Typically, they would work with multiple projects, multiple teams, and their design is very detailed. And then you will have the application architects or the tech leads, where they are focused on the particular projects that they are focused on, and they are more concerned about component reuse in the application that they are working on. So maybe they don't have the full vision of or the sphere of control on what's happening outside of their project. So they are focused on that narrow. But then their work would be highly detailed design, and they work day to day with the developers. So this one is not my take. This is coming from the great source, Wikipedia. So I wanted to share what are the concerns that I'm facing in building the our cloud application, our SaaS offering. So first, selecting the cloud providers. Now, this is not really the call for the developer. Now, everybody would have a saying in this. There are multiple shareholders, obviously, ease of development or quick in going to market. People from the finance department, they will have a say in this. But it really comes down to the architect who's going to be putting on their architect hat and saying, OK, based on these metrics that we have defined, this is what we're going to be going with. Choosing the compute unit and the data storage unit, how are you going to store your data? How are you going to work with this data? How are you going to make sure that it's secure? How are you going to make sure that you have full vision of what's happening in the application at runtime? If something goes wrong, how are you going to diagnose it? Business continuity, how do you make sure that the business is still going to be sustainable and resilient? The apps are going to be available. And governance, how do you make sure that the architecture that you're building today is still going to be relevant and is still in action in a year and a half time or 2 years or 5 years time? So first, choosing a cloud provider, it really, there are so many different factors that get involved, but I just wanted to, I thought of putting what has been relevant to me in the current role that I'm working on. So the type of load that we're putting, whether it's a legacy application, whether it's a modern application, whether there is a PaaS offering that's supporting it, the size of load that you're putting. So for example, if you're going with Azure PaaS, for example, by default, you will get, I think if you go with the standard option, you will get 3 instances. Each would have 1 CPU, I think, or, 2 core. And if you upgrade from that, you get up to 10. Now, that's not to say that Azure cannot give you the full load, but you would need to go with a different compute option. Now, is that going to be the best that you want? So you're going to need to weigh these options to decide what are you going to choose. Now, SLA terms, this is a very common thing to overlook. 2 years ago, I was working in a startup in Melbourne, and we developed this IoT solution. We built it based on top of Azure IoT Hub. And close to the release date, we realized that we made some assumptions because Microsoft talks, if you read the documentation of the IoT Hub, they talk a lot about the throughput and the speed in which that they are going to process these messages and forward them. But what we didn't take into account, latency. And they changed something with latency, and our system started breaking down. And then when we started, after 2 weeks of interaction with Microsoft, realized that there was no clause in the SLA for the IoT Hub that says anything about latency. So Microsoft said, OK, sorry, well, we didn't put anything there because we cannot guarantee your latency. So our design was flawed, and we had to go into like a month of work just to make sure that we can do something that works with the architecture that we built our system on. So it's very important to make sure that you're reading your SLA, you are meeting the terms and conditions that you are required to meet. Certification, so if you are working with financial institute or health, I've worked a lot with health organizations, and they would require certain certifications for the system and where you are deploying it to. Data centers and geo regions, so where are you deploying? If you have This is very important when it comes into data sovereignty. So if your clients are forcing you to have your data within their region or within their country, you're going to need to make sure that there is a region where you are targeting your users. And core services. So if you're going with a hybrid model on-premise and in the cloud, then you're going to need to make sure that there is the network infrastructure, the VPN, whatnot, that's going to help you achieve that. Application services. So what's if you're going to deploy, for example, an ASP.NET application that's targeting full .NET framework, you cannot deploy it as a PaaS offering, for example, on Google Cloud. You have to deploy it either as a container as a service or you deploy ASP.NET Core. So these are also going to be factors to impact your decision, which cloud provider you're going to go with. So one would ask, how about price? How about cost? And cost is a very interesting subject, but you will find that most cloud providers, they provide quite similar numbers when you look at them. And it's very hard to compare them as apple to apple because everyone, they have their own, obviously, features and PaaS offerings, and the numbers are quite hard to match. Plus, there was a survey, I think it was last year, that was 82% of enterprises that were surveyed, they were saying that they wanted a multi-cloud vendor strategy. So they don't want to be locked into one particular cloud vendor. So you would want to make sure that the solution that you're building would be portable. You could span across multiple vendors if you needed to. So choosing a compute unit, many of these things we have already touched on. So everybody knows about infrastructure as a service on the left and functional as a service on the right. On the left, you get full control, you get full overhead, obviously, and there is full cost. There is a lot of cost involved. So if you're spinning up a virtual machine, say in Azure, you spin probably 7 or 8 components. So you have the virtual machine, the compute instance itself. You have the hard drive. You have the network interface card. You have the IP address. You have the network security group. So you pay a lot, and plus you're going to need to manage that, patch it yourself. So there is a lot of overhead. There is the container as a service, which is better, but then every cloud provider would have their own way of providing you with this service. So Google, for example, provide you with Kubernetes, but then they take care of managing the master instances for you, so you don't need to worry about handling all the loads and failovers and whatnot, which is good if you are trying to go into the market quick, but then you're going to need to think about the vendor lockdown. PaaS offering, which is my default option that I go to whenever I start on a project. If I can't handle it there, then I'll go into investigating other options. And then functional as a service. Now, there are a lot of people nowadays that think functional as a service is going to be just the next big thing, and everything is just going to move into functional as a service. I tend to disagree because although functional as a service is great, it's computing as utility. You can put your load there, and then it's just going to be handled for you. You don't need to worry about failover and scalability and whatnot. However, there is more to it than it's just compute. So if you read the terms and conditions from Azure, for example, or from so let's look at this example first, and then I'll tell you about the terms and conditions. So if you look at if your code is there in the function as a service, and typically you're going to have some data storage, say Azure SQL or some other thing, and you're going to have some logging and monitoring tools that you have somewhere in the most rudimental form. If you're scaling your function as a service and you're getting multiple instances, so say you got too much load, it's peak season, Christmas time, and you got too many people coming into your website. This is spanned up. If you got, say, 1,000 instances running at the same time, have you got 1,000 connections going into your database at the same time? Is your database going to be able to handle that? Now, connections is just one way, but how about security, for example? So there are a lot more aspects that you're going to need to think about. You need to think about more holistically. Is your monitoring environment going to be able to handle that load to scale with your compute? If you read the fine prints, they say, we will provide you with all the computational resources required for your instance, for your application. So that's just compute instance. That's not really any other dependencies your application going to have. So that's just one thing to consider. I found this very relevant, and it's very funny. I think last year in Queensland, they built new train lines, and they built new trains and whatnot. And when they came into the release, they realized that they didn't have enough drivers. So they scaled their trains and their train lines, but they didn't have drivers. So they weren't able to change their timetables, and I think they are still suffering from it. So if you read the time from this article, it's still very relevant, September 2017. This was like last year or the year before, and they are still suffering from the same problem. So look at your system holistically. This is the lesson that I have learned. If you're interested in choosing a compute instance, and you want to read about more, there was a great talk by Rob and Matt, who are both in the organizing committee for DDD Perth. They gave this talk in NDC Sydney last month, and I put the link here, so if anybody interested. So the next thing we're going to look at is choosing a data storage. So there are so many variations of so many different offerings for data storage. Where are you going to put your data? How do you make this decision? As an architect, you're going to be held accountable for that, and it's possibly a decision that's going to make or break your application. So for me, when I try to summarize this, so before I summarize it, my recipe normally when I face a tough choice like this, going into a place that I haven't been before, or making a decision that I haven't made before, using a technology or a framework that I haven't used, I try to give myself enough time. So I'll make at least time for 3 or 4 hours of just reading with open mind, critically thinking, forgetting about my biases, forgetting about what I want to do or what I enjoy doing, but just take that time and think about it, read about it, learn as much as you can, and then try to build as much as proof of concepts or side projects, things that you would use as play with to gauge whether this is going to be fit or not. So the first thing in my summary was whether the data is structured or not structured, the volume and the velocity of the data is coming in, the data consistency. So Cosmos DB is becoming now a big thing, or S3, for example, from Amazon. If these vendors are telling you that your data is going to be replicated across multiple regions, and it's great, is your data going to be consistent at any point in time at all nodes? So if somebody made transfer from their bank account in London, and at the same time they try to do the same transaction from their account, but they try to do it from Sydney, for example, is your data going to be consistent in real time? So that's that data consistency. And I found it very impressive that Cosmos DB, for example, gives you the ability to choose what level of consistency you want, whether eventual or strict consistency. But obviously, that comes with a cost. So it costs a lot of money, and performance is not I found it not great, at least in my case. Data partitioning, so that's for SaaS and for performance. So if you're offering a SaaS offering, and you have customer A, and they are all your data is held in the same storage unit, you want to make sure that customer A cannot access data from customer B because they are all in the same database, right? And data sovereignty. So the current application where I'm working on, it's for researchers in government and health organizations, and they want to have data sovereignty. So if researcher is putting their data and doing their surveys, and they are based in the UK, for example, I cannot just replicate their data across multiple regions. Their data has to stay within their region. Or if a researcher is signing up from Australia, their data has to stay within Australia. And that brings a lot of challenges to solve. But it also helps you with making the decision for which storage unit to go to. So 3 years ago, I was working consulting for a big retail company in Melbourne. And I found that they were using Azure Table Storage for caching. Now, everybody would laugh at it because Azure Table Storage are very slow. Everybody who uses them, they would know that they are slow, especially if you don't use the partition key properly. And then I found that the story behind it was that they were trying to use Redis cache, Azure Redis cache, but it wasn't available. It was in preview at the time. And then they thought, well, we're just going to use Azure Table Storage for now, and then we'll switch it later. But it was slowing the system down, actually, rather than giving them any boost, because you're trying to use caching to speed up your application, but obviously you're getting a penalty. So I have a small demo. In this demo, I'm just going to show you, so I'm taking some data, checking for system status, taking the data, putting it into Azure SQL, and then taking that, putting it into an Azure Cosmos DB, taking it from that, putting it into Amazon S3, and then putting it into Google Cloud database. Now, there is no application that's going to do all that, obviously. But it's just a way of showing you my very rudimental proof of concept for checking the timing and whether it's going to be suitable for my use or not. So if I'm going to start this. So what's going to happen while it's running, I'm going to show you. So basically what we have here is, oops. What we have here is I'm getting the system status, and I'm starting a stopwatch, inserting it into Azure SQL database, and then taking it from the Azure database. Okay, that's all right. And then inserting it into Cosmos DB, taking it from Cosmos DB to Amazon S3, and then taking it from that into Google Cloud. So although everybody would agree that this is nowhere close to a good proof of concept for timing, because there are so many factors that you're going to need to take into account, what's the tier that you're taking from each. But even with the simplest proof of concept, you can find that the timing is quite different. So if I'm trying to make a decision and timing was more important to me than consistency, for example, I'll be leaning towards, for example, S3 or maybe Google Cloud Database for reading. Is it easy to read? Sorry. No? Okay. So let's try. Oops. Is it easier to read now? Yeah. So you will see that if I'm trying to, you will see the difference here. In reading, it's 200 milliseconds, but in other instances, it's much longer. So here, for example, Google Cloud Database taking 700, and even with the most rudimental, the free tier from Azure SQL Database, it's giving me less time. So with write, you will find even more variation. So this is like 3 times the amount of time that's taking for writing. So it's very easy to spin up these kind of things. Sorry. So it's very easy to spin up these kind of proof of concepts, and it would help you to make the right decisions on whether this is going to be fit for you or not. And obviously, it's going to be dependent on your circumstances and your data that you have. I'm going to be sharing the code on GitHub after this, so if anybody is interested, you can get access to that. Okay. Cool. So security, with security, really the objective is always confidentiality. The data is not accessed by anybody. Integrity, the data is not tampered with or destructed by anybody. Availability, the system is resilient against distributed denial of service. And accountability, if something goes wrong, we have traceability. We have something that we can rely on to give us the picture of what's happening. So in terms of approach, the standard, I'm not claiming to be an expert in security, but this is what I do. Authentication and authorization is normally standard. Information hiding, whether it's by cryptography or by naming your data differently. Auditing for intrusion detection. And so interesting, you'll find a lot of cloud providers provide you now with platform as a service for intrusion detection, for detecting any malware or any malicious attack or malicious access to your data. Multi-security layers is thinking about your security in all the levels that you are accessing your data. And using the tool. So there are many tools. I use Sneak, for example. It helps you with identifying any vulnerabilities in your data, and it helps you solve them. So again, operations and monitoring, I think we touched on that. Real-time monitoring, is your monitoring platform going to be scaling with your compute and data instances? And choosing the right platform and framework for the job. Traceability. So if you have a cloud operation, it's more likely that you're going to have multiple components and multiple apps that are running at the same time. So you would want to make sure that you have a way of correlating the messages and the data going from one end to the other. So normally you would use some correlation ID or something to track all the messages to see what's happening in real time. Application profiling to make sure that the application is doing what you want it to do or what you're expecting it to do. So business continuity. Now, what happens if your database was deleted? So think about that for a second. Let that sink in. Like, many people would not really take that into consideration, but there was a long conversation on Twitter about 2 months ago. A junior developer just started in a job, and the first thing that they did, they gave them a document, set up your system, and they just deleted the database. Now, for whatever reason, that was a stupid case, and they were blaming the junior developer for it, which I don't think he's liable for it. But it happens. So even worse, what happens if your Azure account or AWS account was deleted? And then you take that further, how consistent are your build and your configurations? And ultimately, the question is really here that we're trying to get into. How hard is it going to be? How long is it going to take you to get back online? Now, if you are a developer, you're going to be in a deep shit. But if you are, and sorry for the expression, but if you are an architect, you're going to lose your job, and probably you're going to be even liable because you are accountable from the organization that's entrusted in you. You are liable to make sure that the system is available, and these are your decisions that's going to make the impact. A couple of, I think last year, I was doing a contracting gig for a mining company in Melbourne, and we built this simple application. We went with PaaS offering on Azure. Towards the end of the project, they said we have this risk matrix that we want to meet, and we want to make sure that if Azure goes down, we are still able to function. So they wanted to have a backup on AWS. And I was thinking, like, why do you have to complicate things? Azure gives you 99 point something, so that's probably going to be cool. The next day, Azure was down for 1.5 hours. And it was really terrible. I got pulled into a meeting, and I had to explain to the CTO what decisions I have made. Obviously, I was close to losing my job. Luckily, I was able to survive from that. But it's really a lesson that we need to learn. You need to think about these before they happen so that you can prepare yourself. So lastly, governance. How do we make sure that the architecture that we're putting today is still going to be relevant and we're still going to be able to use and comply with it in the time to come? So this is really more about, there are two folds for it that I see. One fold, which is defining the rules and getting the buy-in from the people in your team. So defining to everybody what's the style of architecture that you're using, whether you're using event sourcing, whether you're using CQRS, or whether you're using anything else. So you want to make sure that everybody understands what style of architecture that you're getting to, what patterns are you heading to. And then the second fold is using those really tools to enforce that. There are great tools by a guy called Andrew Best from Sydney. He's I think a Redify consultant. I really love these tools. So AlTaiar, for example, gives you the ability to enforce your assumptions or requirements. So if your database query is taking longer than X amount of time, you have tests that's going to fail in your CI/CD, and developers are not going to be able to continue without fixing that. Or conventional, for example, if you are following, how many people use domain-driven design? Yeah, great. I think most people would agree that when you start with domain-driven design, it's great, everything is clean, everything is tidy. The more you're going to move on, the more you're going to find that people come into the team, they don't really comprehend the full concept of domain-driven design, and then they will start changing things. So one basic thing about domain-driven design is that information hiding. Information is not available, and then you put your boundaries, and everything changed through methods or contracts that you enforce. Somebody would come in and then going to make all this data available, so everything has a get and set, and all the concepts and all the considerations of DDD just thrown out of the window. So you want to make sure that this is all enforced in your code and in your test. And conventional is great. I'm going to show you a demo in a second for that. So this is really the same in point 2, which is executable documents. Non-functional requirements must be enforced. So if you are required to have a performance time no more than 5 seconds, then that really should be part of your test, so that if your system is taking more than 5 seconds, then you should fail the build, because it's a requirement, and you're not going to be able to go without it. Traceability. This is very important if you're doing anything in health. So when I was working in health, we were required to show a full traceability for every line of code where this is coming from. So we wrote this extension for Jira, and it was taking the acceptance criteria from Jira, generating the feature files, and our testers were working with the feature files just to do the automation testing. So no need to worry about manual testing. It's all automated testing. And then the automation testing is feeding back basically saying, OK, which line of code it's pointing to, or which feature it's pointing to. So that was really helpful. And in the end, it's really getting the buy-in. With all the technology, if you don't have the buy-in, people are not really happy to contribute to it. So without explaining the why for your team, you're not going to get anywhere. All right, so we have the second demo. So can you see this? So this is a standard aggregate. If anybody used DDD, you would find this relevant. So you have the aggregate root here. Can you read this? No? Yeah? OK. So basically, it's saying that I need to have a protected default constructor for my entity frameworks, so that it can use that for serializing my objects. I need to have constructors or factor methods to generate those. And all my properties need to be protected. So I need to have only private sets. So this is what we were talking about now. A year or 2 years later down the track, you get somebody just coming and joining the team. They don't really have full comprehension of DDD. So they go and add a method, and they say, for example, so I'm going to add, oops. Now, I'm having a public set here. This is throwing DDD concepts out of the window, because you're really not having any way of enforcing how these fields are going to change. So now if I run my test here, you're going to see that my test is going to fail. And this is really great, not only for enforcing the design concepts that you have embodied in your code, but it's also important for shortening that feedback loop. So normally what would happen with a scenario like this is that somebody is going to add this code, going to push it in. It's going to come to you, whether you are the technical lead or the solution architect. You're going to review it, and you're going to say, nope, rejected. You're going to need to look at this. But this is taking so much time. It's taking time from you as the architect or technical lead, as well as the developer. If you have something like this that's automating it, you're going to speed things up and make things easier for yourself and for other people. So if we look at the test that we have here, all we're doing really is using reflection. We're just loading all the aggregate roots, and we're just saying, OK, all aggregates must conform into this standard or this style. And there are so many of these standards and styles that are available for you. And they are all built using Roslyn, so you could extend them if you want to. I find it really an interesting tool, and I use it a lot. I hope you find it. And there are a lot of other things as well. Like, for example, if somebody is using datetime.now, for example, how many people use that? But then it makes things really hard to test. It makes things really hard to predict, and you don't know when it's going to just blow up in runtime. So you want to make sure that these kind of things are enforced. So going back there. OK, so we looked at that. So I hope it wasn't very fluffy. I hope you find that there was something useful in there. And again, if there was anything that I would want you to take away from this, if you're reaching into something that you haven't done before, give yourself enough time to think about it. Normally, I give myself at least 3 hours of just reading with an open mind before I try to make any decision. And if I haven't really used it, at least in a side project or in a proof of concepts, I wouldn't be able to use it for production. It's just I'm not really qualified enough to go and use that. And that's really all. Any questions? I have two small things here to give away if anybody has any questions. No? Yeah. True. I try to make sure that, obviously, you got to understand, I've only been a solution architect for a short time. So, but my way is always trying to make sure that I'm working with all stakeholders, so being the developers, the enterprise architects, or the security teams, the operations team. What I have seen, normally the case in my consulting career, is that companies tend to, or teams tend to leave things until the last minute, and especially when it comes into security or operations. And that tend to create big gaps or create scope creeps toward the end of the project, and everybody would become unhappy. So I try to make sure that I engage people as early on as possible. That's my only approach. Yep. A lot. So when I moved into this role, I was interviewing for 3 roles. 2 of them, they wanted a solution architect that is not really coding. And I didn't want to be rude, so I said, yeah, sure. But I didn't really want to progress because I wanted to make sure that an architect is still coding. If I'm not coding, I'm not going to be able to feel the pain or get the right feedback that developers that they are giving me. And that's why I went with the current role. So normally you will find me at least doing, I try to say 10 to 30% of coding. Sometimes that doesn't happen. But I try to stay as close as possible to the development team. Yeah. So the question is how hard it is to learn, or how much time it would take you to learn the domain of the new organization or the processes of the new organization. Now, I think what helped me was for the last 3 or 4 years, I was working as a consultant. So I have had gigs that lasted a week, and I was under the pump to deliver something in the end of a week, and I had gigs that lasted 3 or 4 months. So that helped me a lot, set me up for being able to switch contexts and go into different organizations and get productive as quick as possible. But it's also about making sure that when you're going into the organizations, you are connecting with the right people and getting the information. In many scenarios, I found it really hard to get the right information. The information is there, but just nobody knows where it is. And it's just part of the game that you're just going to have to dig that in and talk to the right people, try to talk people, and people are going to lead you into other people to ask. Sure, yeah? Yes. So I talked about making sure that I'm reading enough for it. That's a really key element for me, and I found that really helped me a lot. But normally, if we are trying to introduce new technology, we need to have an agreement. The developer that's introducing, or the team that's introducing this new technology or framework, and myself or whoever else is involved, need to have that agreement. Now, normally, as technologists, really, we are very passionate about new technology, and myself included. I love when I hear about new framework, and I just want to get started into coding and using it. But then you want to make sure that you are addressing the risk, because every technology that you are adding, it's a risk. Do you have the right tools? Do you have the right people, the skill set to be able to and productive with it? So normally I try to have, it's kind of like a checklist, making sure that do we have something that does that? Are there gaps with the one that the tool or framework that we're using? Is there a justification for introducing this tool? If there is, sure, let's use it. But let's understand whether there are any other tools. And in many instances that I have seen, there are tools that are there. I'll give you an example. I think it was last year. We're using Spec 4, and I don't know how many people use Spec 4. It's great for auto mocking. So if you are doing testing, somebody's going to disagree with me here. But if you're doing unit testing and you want to auto mock certain elements, you don't want to focus on this. You want to focus on the piece that you are working with. We're using Spec 4, which was great for that. A developer came to me and he said, I'm going to use auto fixture. Why do you want to use auto fixture? Because auto mocking doesn't do this and that. OK, so let's look at the documentation. Looking at the documentation for about 10 minutes solved the problem that he was trying to have by introducing this new technology. There is nothing wrong with introducing new technology, but as long as we have the right reason for it, great, let's go for it. But sometimes just asking the right questions, you're going to find whether there is a real need for it or whether there is not. I hope that answered your question. Any other questions? Yeah? At the moment, I'm actually permanent. It's interesting. If you look at my profile, I haven't stayed in a place for more than a year and a half. So I've moved a lot, and I think that helped me a lot in being the person I am, learning a lot about other domains and learning about how other companies are doing things. But in going into an architect role, you're gonna need to have some long-term engagement. But I found it interesting that many companies are willing to take somebody for an architect role for 6 months or a year. At the moment, I'm currently on a permanent base, but I'm still weighing my options. I'll be very honest with you. I haven't really made a decision. I'm still thinking whether I should go back into just being a developer, because I think I enjoy my time more, just focusing on the technical side rather than focusing on stakeholder management. I'm still trying to work out my decision, but I was looking, and there are so many jobs, even enterprise architects, which is like more strategic and more visionary kind of role in the enterprise, and there are contracts for 6 months or 1 year. So if I wanted to do that, or if somebody wanted to do that, you can still do that. Right? Yeah. There is for, obviously, there is probably more legacy code in the industry than Greenfield. At the moment, because there are so many new concepts coming up, whether it's virtual reality, IoT, machine learning, artificial intelligence. So there are a lot of new development going up, so there is more Greenfield. But there is a lot more legacy code as well. So I've done a lot of legacy engagements myself. So the engagement that I was talking about for 1 week, that was actually for a utility company down in Melbourne, where they had a contract with the Defense Department, and something wasn't working, and it hit the fan. The Defense Department told them, OK, we're going to cancel your contract. So they got me in, and they told me, OK, you're going to need to find this. It was an Android application connecting to the cloud, and it was just timing out, and it wasn't logging them off. So my engagement was just to make sure that what's the problem, find the problem first. And the first week was just really just finding the problem. And I found the problem in the first 3 days, I think. And then after that, we went into the second phase, which took about, I don't know, probably 2 or 3 weeks for them to go through the process and sign the purchase order or whatnot. And then we put a fix for it. So I've done legacy code as well. And there is more legacy code, actually, especially if you go into finance institute. There is more legacy than Greenfield development. Yep. It depends on the organization and the role that you want to play. It is an advisory role, but I don't really like to be an advisory, so I want to make sure that I get my hands dirty, and that's why I'm saying I went into the third role rather than the first two roles. So it's really depends on you and the organization that you're going to. Okay, so the first two questions, the people that asked, sorry, I don't know your name, so your gifts are here. Thanks. Thanks, everybody.